Hello everybody. Today I want to explain how a double ratchet works. This is a cryptographic algorithm used in Signal Messenger, for example, but also Facebook claims that they are using it in WhatsApp. And Facebook Messenger, if you happen to create a secret or protected communication channel in Facebook Messenger. I anyway have banned all Facebook apps from my phone, so I'm not using WhatsApp anymore. I still have friends, but only nerd friends, of course. Anyway, I had only nerd friends before. No, so the thing is, for business or for work, we are using a lot of Slack, and that is not end-to-end encrypted. So a couple of clients I have, they are also using Signal. So we started to use the group chat functionality of Signal, and I've added another client to the group chat, and then he was complaining that he can't read the past messages. Then another client said, yeah, this is because of the double ratchet algorithm of Signal. And then I actually thought I have to dig into this, and it's quite interesting, so I want to share it. So the double ratchet algorithm is actually, or let's say a ratchet is a one-way function, most probably a hash function. And in this hash function, you use the output of the previous key derivation function as input to the subsequent key derivation function. So that actually means you can't go backward in time, and that's actually perfect backward secrecy. The thing is, if now the key is compromised, then everybody could call this key derivation function and create the keys for the new messages, and therefore seize the new messages. Therefore, you need a double ratchet. So actually there are three ratchets. There is a sending ratchet and a receiving ratchet. So if you send something to somebody else on Signal, you always call the ratchet or the key derivation function with your current key and obtain a new key, and that's actually used for encryption. And on the receiving side as well, if you receive a message from somebody, you advance your ratchet one step, and that's also what the sender did. Then you have actually the same key. So those two ratchets are basically considered as one conceptually. And then there is a different ratchet. This is a Diffie-Hellman ratchet. So whenever both parties are online at the same time, Signal uses this Diffie-Hellman ratchet to derive a new key from that one. And that new key is used in the two other ratchets, in the sending and receiving ratchets, as an input to the key derivation function as well. So this means even if the key is compromised in the middle, through the Diffie-Hellman ratchet, the seed of the key derivation function is updated regularly on a regular basis, and whenever that happened, then even if the key is compromised, the attacker can't read the future messages. So that way you have achieved perfect forward secrecy and perfect backward secrecy. So remember, with a single ratchet or only the two sender and receiver ratchets, you only achieve perfect backward secrecy. But if you want to achieve perfect forward secrecy, you also need the third ratchet, which is the Diffie-Hellman ratchet. Yeah, I hope this is a little more clear now. There are very detailed videos on YouTube, and you can then also watch those if you are interested in getting more details. So have fun, stay healthy and peaceful. All the best. Bye.